Before we start, just to wake me up and you guys up, although I do have a good spotlight here, a couple of quick questions so I know who I'm talking to. So everyone here is a Red Hat customer, I presume, or employee. It's an easy one. Keep your hands up. If you aren't using virtualization, put your hand down. If you're using KVM, put your hand down. If you're using Hyper-V, leave the room. So the rest of VMware. Okay. Any OpenStack deployments so far? Any Rev deployments so far? Okay. Okay, so my name is Andrew Cathrow. I run the product management team in the virtualization business unit, so I look after all things virtualization. Today we're going to talk about infrastructure as a service. More specifically, we're going to talk about OpenStack, talk about Rev, and talk a bit about some of the technologies behind them and some of the architectures in the cloud. I want to start off by talking about service models and workloads running inside VMs. Why does that matter? It matters because the definition of cloud for many of you will be different. So for some people, cloud is virtualization plus self-service plus some form of reporting or chargeback. Now, if you're doing that, that's probably more than most people in the room, and that's a great start, but that's not what I would call cloud. Cloud isn't about the outsourcing your virtualization infrastructure to another venue. It's not about the location of the VM. It's not about how you start the VM or how you charge for it. It's about how you build and deploy your applications. So before we talk about OpenStack, before we talk about Rev and some other products, I want to talk a bit about these service models and the workloads. So let's start with a traditional workload. Now, some people call these legacy workloads. I'm uncomfortable calling them legacy because it's what 95 to 98% of your workloads are. And if that's legacy, we're all in trouble. So a traditional workload is really modeled from a physical machine. It probably started off in some fashion physical, converted to a virtual machine. The application will be stateful, so it's got persistent disk. An application is tied to that virtual machine. So if the virtual machine goes down, the application goes down. So if I want the application to have a high SLA, I need the VM to have a high SLA. So I click a checkbox in Rev or vSphere or Hyper-V to make it highly available. If I need to scale it up, I've got more load, I add more CPU, more RAM. The application will be up for months, maybe even years, so a really long life cycle. And the application was not designed for tolerance, so it expects the infrastructure to provide certain services. So services that you're used to with VMware or Rev or Hyper-V, like live migration, vMotion, storage live migration, high availability. These are services that the application needs, but it doesn't handle those natively. If I contrast that to a cloud or elastic workload, I think elastic is a better description than cloud. Too many things are labeled cloud today, it gets confusing. So a cloud workload, the VM's typically stateless, a ephemeral VM. So you boot it up and it's got no state. It reaches out to a config server to get its identity, to know its name, the application profile, and the configuration. The application is not tied to a single VM. The application is distributed on many VMs. So the SLA isn't tied to that one single VM. VM1 dies, it doesn't matter. VM2 is servicing workload. So the SLA requirements are just driven by the fact that we need to have more VMs and some service to spin up more VMs, create and destroy them as load demands. I need to scale it, I add another VM. I don't have to increase it, I just go horizontally. So typically these VMs are smaller. It may be more efficient to have many small VMs and very large VMs. The life cycle may be hours. Maybe it's just up for lunchtime to handle the influx of orders, and it goes away at 2 p.m. The application is designed to tolerate failure. It's designed to be elastic. It's designed to understand that it may disappear. So it needs to handle sessions, state distribution. So it's a new way of developing an application. Now, if you're developing applications today, you would do it more in this model. Right? It's a very elegant model. It allows you to scale. But again, 95% of your workload wasn't written this way. Now, if I take a cloud workload, I can easily put that on traditional data center virtualization. Right? I mean, it doesn't require any of the fancy features. It will just run as a VM. Now, scale may be a problem if I have to go to hyperscale, thousands of nodes. But in terms of functionality, should be no problem. Run a cloud workload, an elastic workload on your traditional data center. Any of you heard of this analogy before, pets and cattle? So the credit depends who you talk to. Different people have taken credit to it. The best that we've got is either Bill Baker at Microsoft or Tim Bell at CERN. I'm inclined to think it's the guys at CERN rather than Microsoft, but I could be wrong. So analogy comparing pets and cattle with these two workload types. Now, I did this presentation a few months ago, a similar one to some friends and colleagues in APAC, and they warned me that I had to be careful how far I went with the analogy because in some cultures, cows are sacred. Okay, fair point. I won't kill the cow anymore in the analogy. So one of my colleagues had a great idea and redid it with farm animals. But I had to explain that in IT circles, bacon is sacred, so we don't mess with the pig. One of the guys on my team did a presentation this morning on OpenStack, Keith Basil. If you saw the presentation, a great analogy using a school of fish. Now, I wanted to have something myself, something that was unique. The fish one was great, so I've been working on this one. It's not quite ready for the prime time yet. The squirrels and the nuts is not quite PG, so I'm going to go back to the tried and trusted analogy of pets and cattle. This won't kill any more cattle. So pets are like traditional workloads in the data center. Pets are unique. You care for them. They're part of the family. You give them a name. If something happens to the pet, you take it to the vet. You nurse it back to health. Right? Just like your mail server. If something happens to mail@reddit.com, we're going to fix it. We're going to get to that server. We're going to fix that instance. We may have to edit some config files, go back from a backup, but we're going to fix that instance. The cloud is like cattle. You have thousands of them. They're almost identical. They're given numbers, not names. You don't have a relationship with one. Right? If node 42 dies, node 43 takes over its workload. So if one gets sick, you get another one. It's no big deal. So that's a comparison between the workloads in the cloud and the workloads in the data center. And why I harp on about this is because these requirements drive, these application requirements drive requirements of your infrastructure. If you go back to, away from analogy, back to the workloads here. Now, an application that isn't built to tolerate failure, one that expects to be up, needs a high availability infrastructure. You may need to have live migration, storage live migration. You may need to have some form of DRS or a system scheduler. So the choice of workloads dictates where you're going to run them. So a cloud that doesn't give you high availability, a cloud that doesn't give you some of the pet features, you may not want to deploy your data center applications on that cloud. Again, it's easy to take a cloud workload onto the data center, but not the other way around. So what are we today? I would guess, if you're like the rest of the customers I talk to, 95% of what you have is on the left, is a traditional workload, but your goal is to move to the right, to have more elastic applications. The things you're building from scratch are elastic by nature. In many cases, what you're building, what you have today already, you're trying to make more elastic. There's nothing wrong with having pets, right? You need to have these workloads. You don't necessarily want to have all pets, but I've got 2 dogs when I get home, that's great. As long as they're trained, and especially house trained, it's fine to have pets. So your large mail servers and databases, I'm not saying that you should eliminate those in favor of a cloud or elastic database, but we need to balance where we run the workloads based on the requirements of those applications. So where are we today? So a lot of you had VMware. Some of you have VMware, didn't admit to having VMware. But you're running VMware today, and it's looking after a lot of your pets. So traditional workloads are running on vSphere. Over the last 3-4 years, we've been talking to you about KVM and moving from a proprietary virtualization platform to an open platform, so Hat Enterprise Virtualization. And what we want to do now with you is take you from the data center through to the cloud. So the difference between the private cloud and the hybrid cloud. So a private cloud is something that is inside your data center, right? Whether that's something you build on top of OpenStack, Rev, or some other platform, it's inside your data center. A hybrid cloud is when you have parts inside and outside of your data center. Maybe I want to burst to Amazon or to another cloud provider when I need more infrastructure. So our goal is to help you go from proprietary virtualization to an open virtualization platform, and from there to cloud or elastic architectures using OpenStack. So I want to talk about some of the building blocks that we have in the portfolio to build an infrastructure as a service, and introduce a new one to you, the one that's grayed out at the top. So Rev, Hat Enterprise Virtualization, think of this as being an open source competitor to vSphere. So it's vSphere for KVM. In honesty, we spent 2 or 3 years playing feature catch-up with VMware. I think we got to the point with 3.1 where we're no longer having the conversations about do you have feature X, Y, and Z. We've addressed the matrix or enough of that matrix, and we're now differentiating whether it's price, performance, or some new features. There's a session going on, sadly next door, right at this time, about integration of Red Hat Storage Cluster with OpenStack and Rev. So we're doing things now that the proprietary vendors can't do. So leading performance in terms of scalability, whether that's large VMs or density of VMs, typically 30 to 40% cheaper than vSphere and open. And for those of you who think that KVM is only for Linux, we do a lot of work at Red Hat to make sure that Windows runs really well on KVM. In fact, I'd argue it's the only safe way to run Windows is contained within a virtual machine on KVM. So take SE Linux, we put a container around Windows, and if you have to run it, let's do it securely. In terms of features that we have within Rev, so it's a centralized management platform. You shouldn't have to touch the command line. Of course, if you want to, we have CLIs, we have APIs, but everything should be GUI-based drag and drop. If you've not tried Rev, down in the exhibition hall on the second floor, just go to the booth, they can show you Rev and OpenStack. So high availability with a single click, vMotion or live migration, storage vMotion, storage live migration, dynamic load balancing, power management, templates, thin provisioning, all the features that you'd expect in a virtualization platform. And then V2V and P2V, so virtual to virtual conversion. You have vSphere today, then we can point a tool at your vSphere instance, pull out the VM configuration, and it'll be running on top of Rev in however long it takes to copy the disk image over. You have a physical machine, boot an ISO, either a CD or a USB key, and we'll migrate that physical instance to a virtual machine. Of course, self-service and reporting. Now that doesn't make it a cloud, well, not in my definition, but it gives you the ability to rapidly provision new virtual machines, empower your users, and do either show back or charge back. So what is OpenStack? I reviewed a lot of summit presentations this last few days. I think I saw 6 different presentations that did what is OpenStack. So I'm not going to do all of what OpenStack is. I'm going to keep it at a very high level. But actually, how many people haven't heard of OpenStack? Even my mother haven't? Okay, even my mother actually asked me what OpenStack was a few weeks ago. So OpenStack has got all the promise of Linux. What we're seeing in OpenStack is an enormous community growing tremendously. I would describe OpenStack, if at a very high level, it's building blocks. So today, OpenStack provides you building blocks to build a cloud. So it's a set of modular services that I can take these services, so an image service, a network service, compute, hypervisor, and put it together to build a cloud. Now, it was designed for massive scale. Right? The history of OpenStack, it really came from cloud envy. Amazon had this great EC2 cloud. Everybody wanted to compete with Amazon. And OpenStack and Eucalyptus were 2 projects that had a goal of replicating the functionality of EC2. Eucalyptus was I think, slavishly copying, even down to the API level, where OpenStack was taking the principles and building a project around the principles of a cloud with the elastic elements that we discussed. So again, built to scale to thousands of nodes, designed for cloud workloads. So often when people look at OpenStack, they come back and say, well, I don't understand, why don't you have this live migration or storage live migration or the HA feature you have in Rev or vSphere? And that's not a deficiency in OpenStack. It's really a design tenet of it's designed for elastic workloads. It doesn't mean that we don't strive to get some of those features into OpenStack, but again, it's targeted for elastic or cloud workloads rather than being a cloudy vSphere. Anybody here seen CloudForms? Again, another great product I would look at downstairs in the exhibition there if you get a chance later on this evening. So CloudForms, and this isn't my product, so I'm going to describe the way I describe it and upset my peers who own CloudForms. To me, it's operations management. So infrastructure management is, here's the bare metal, I'm going to provision hypervisor, storage, and networking. Now, CloudForms presumes someone's done that. You have cloud virtualization. That could be Rev, that could be Hyper-V, that could be vSphere, could even be Amazon EC2. And it provides a consistent set of operational services on top of that. So you want to do compliance, you want to do reporting, you want to do self-service, you want to do some kind of orchestration, you want to do chargeback. These are features that it provides across all the platforms it supports. So if you wanted to schedule a VM, based on the VM, it will know where to run it. Maybe based on capacity, I can't run this VM in-house, it's going to have to go to Amazon, I'm going to burst. Or maybe based on the characteristics of this workload, I'm going to deploy it on a Rev infrastructure or on an OpenStack infrastructure. So see this as a single pane of glass for the operations manager and even for end users for self-service. So if I wanted to put together a solution for infrastructure as a service, one approach I could take is this picture and say job done. I've got CloudForms for operations management, and below that I've got Rev, OpenStack, and optionally VMware. But realistically, VMware is going to be there. I don't know any customers who aren't deploying some form of VMware. The reason, by the way, for the missing line on the right, today we're still adding OpenStack support into CloudForms. You'll see that over the coming months. So I think that's going to be covered in the CloudForms Roadmap session this week. So does this address my problem? If I have CloudForms now doing the right orchestration, be it to the right virtualization platform, the right private cloud, or the right public cloud, does this address my need for a flexible infrastructure as a service? I would argue not yet. If I go back to the picture of the OpenStack architecture, I've highlighted a line here, which is a modular set of services that we're delivering with OpenStack. So unlike vSphere, unlike System Center, Hyper-V, and Rev, OpenStack is very modular, not monolithic. So why does that matter? Look at this picture. Once I've deployed my infrastructure, VMware, Rev, OpenStack, great, I can now manage it. But below the line, I've got to manage 3 sets of storage, network infrastructure, hypervisors. How can I actually simplify my management, simplify the infrastructure? So I'm going to take a look at 3 of the OpenStack services and look at how these can actually help us across the board. So OpenStack image service, codenamed Glance, is a very simple service that allows me to store an image. So I can put an image that's like a template or an ISO or a disk image. So get an image, put an image, and get metadata about an image. Very simple service. For networking, the Quantum project, it's a plugin framework for software-defined networks. So I can have plugins for Open vSwitch, for Cisco networking, HP, IBM, etc. And then Cinder is a volume or block storage service. So if I want a persistent disk, an OpenStack, Cinder provides me my disk service. So I can create a volume, snapshot a volume, attach it to a running VM. It has plugins like with Quantum, so you can extend it. So you could have a simple plugin that does this Linux LVM, or a more advanced one that talks to a NetApp filer, HP storage, IBM storage, etc. So what we're working on today is how can we simplify the architecture? While this picture here looks pretty, especially when we finish on that last line, it hides the complexity below the line, the duplicated infrastructure, networking, storage, management, etc. So we're working on a model of shared services. So how can we break down the silo between cloud and data center? We don't need to have to deploy a silo of your data center virtualization and a silo of infrastructure for cloud. How can I eliminate that duplication? How can I share that infrastructure, whether it's shared storage, networking, management APIs? So by sharing it, I'm going to both simplify the architecture. I've got a common set of skills that can be used on the infrastructure layer. I can optimize development. I don't have a team developing storage features on Cinder and Glance and storage features on Rev. And can facilitate the transition from traditional to cloud or elastic workloads. What if I had a virtual machine that I built within Rev and it's suitable to run on the cloud? So if I could just export it from Rev into Glance and then consume that on a Nova compute node with an OpenStack infrastructure. So what we're working on today is this integration with the common services between Rev or Overt, which is the upstream, and OpenStack. So you want to deploy a common set of shared services, so KVM hypervisor, Glance, the OpenStack image service, Quantum, the network service, and Cinder, the volume service. So you've got a common set of infrastructure components with the exception of the controllers, and a single pane of glass using CloudForms. So the goal would be that you can have pets and cattle running on common infrastructure without compromising on SLAs, features, or scalability. So fleshing out the picture. So there's some lines here that have been drawn that I'll talk about where we are with roadmap and delivery. So CloudForms managing OpenStack, and semi it can manage VMware and Rev and Hyper-V today. So that's work in progress. What we're working on right now is this service consumption. On the left, the storage services, that's Cinder and Glance. In the middle, Quantum integration. And Keystone is the authentication system in OpenStack. That one isn't necessarily a feature, it's really a prerequisite for us to deploy on top of OpenStack services. Based on time, I think I've got a couple of minutes just to pause for a second. So any questions on this slide? It's fundamental what we're doing. It's very different than what else is doing. Any questions before I move on? No questions is either really good or, oh, now I have a question. Let's see, is it good or bad?
So would Glance and Cinder for Hat Enterprise Virtualization be in addition to traditional centralized?
So the question is, would I use, so in this picture here where I'm using Glance and Cinder, would that replace what Rev has or supplement it? So initially it would supplement it, would have both as a transition, but over time, we don't want to maintain a template store for both systems. It's a very simple thing to replace. Cinder will come a little later. We'll see this in the roadmap as it needs more features to replace the Rev storage domain. It's not got enough features today for all these cases that we need, but I see them as being initially side by side, and then we'll phase out our dedicated components. So move to this common services layer. Why it's interesting as well is that it allows you to slowly make a move to OpenStack. We mentioned that maybe 90-95% of what you have is expecting virtualization infrastructure, and only new workloads you're developing or simpler ones are appropriate for OpenStack. Well, what if you today can start deploying that infrastructure? You can start deploying the shared services. So you're building a software-defined network around Quantum, with all the huge ecosystem of vendors around it. You're leveraging storage offload, advanced storage features with Cinder, having a common service catalog that everyone's using based on Glance. So rather than having these silos, we can give you a simpler transition from traditional data center into the cloud.
So I know CloudForms isn't the basis of your discussion here today, but what is the capabilities of it or the possibility of dropping right here that represents a physical infrastructure as well. It says, I also, in a traditional sense, need to be able to perform all of those services
Yeah.
at the top across a physical infrastructure that shares common hardware, but across those 4 now platforms as opposed to the 3 virtual platforms.
It's a very good question. I know that the satellite components and the whether it's Foreman, Cathrow, etc., and friends, they're going to service both physical and virtual. These services here in CloudForms, I don't know, but there are some CloudForms, a lot of CloudForms sessions in the rest of the week, and the guys downstairs in the expo hall could answer. But it's a great. If this goes to physical as well, but really it spans out to public cloud as well. I've not put Hyper-V on here because if you're going to put all your eggs in one basket, that's not the basket, but it covers more. So it would make sense to be physical, but I couldn't answer that for that team. One more question, and I'll move on.
So you have the definition in this long-term outlook in RAM KVM, and there are some overlaps in terms of functionality. So do the definitions stay even after RAM workload, completely on either RAM or KVM?
I think if you look at the picture today, if I rephrase the question, I get asked a lot, are we deprecating Rev? And the answer is no. But I think today you've got, let's say 95% of workloads are traditional virtualization, a small proportion are elastic applications. That's going to change over time, right? And that's going to change quickly based on the momentum that we're seeing. So I think, so over time we'll see that change. There's always going to be traditional. Traditional eventually becomes legacy. I think anyone here deploying Satellite 5, I don't know how many years that's been running for now, but it's a great product still run, lots of customers using it. You always get legacy applications, one that are running for a long period of time. I don't see Rev going away anytime soon. I see the use cases change, and I see the shared services adapting, and more things running on OpenStack than on Rev. But it's not going to be a switch that flips. It's going to be a gradual drain from, not from Rev to OpenStack, but from traditional to elastic workloads. Yeah. The ones that are appropriate, like HA, I mean, some part of HAs within heat, we'll see those going into OpenStack. But when you look at like systems get like DRS type functionality, storage vMotion, those aren't things that are even on the horizon for OpenStack. So I think there's always going to be a need for traditional virtualization, but again, the balance will change. So Paul hinted at this in the keynote. There was a session early this morning that introduced Red Hat Cloud Infrastructure, R8CI. And there's a recorded webinar that was I think 1 o'clock earlier today. So what we want to do is make it easy to consume these technologies. So we're seeing a subscription that provides a complete open cloud, bridges the traditional cloud and elastic workloads, providing both sets of services, along with the management on top of this. So R8CI, which we love our acronyms, will include CloudForms, will include the RHEL that's required to run both the host infrastructure as well as guests, OpenStack and Rev. And sometimes I ask, why OpenStack and Rev? Why is it not either or? Let's say you had 200 sockets of R8CI. You may find that in the first year you're running 80 sockets of Rev, 20 sockets of OpenStack. In the second year, 70, 30, etc. So over time that change. So by the common infrastructure, we have the common services, and then over time, you may have a different balance of traditional workloads to elastic cloud workloads. The other product that we announced this morning, must we love a good short name, Red Hat Enterprise Linux OpenStack Platform. I'm just going to call it ROS, Red Hat OpenStack. But Red Hat Enterprise Linux OpenStack Platform is the combination of RHEL and OpenStack. So it gives you, for the sockets that you buy, unlimited guests as well as the host infrastructure. So OpenStack integrated with and optimized for RHEL. So a lot of work is done. We don't just compile and ship code. A lot of work is done to optimize OpenStack on top of RHEL. We spoke this morning briefly about the certification ecosystem. You'll hear more about that over the coming months. We already have literally thousands of certified applications and hardware platforms certifying on RHEL OpenStack platform. So 2 ways you can acquire OpenStack from Red Hat, either as the standalone offering, OpenStack platform, or within R8CI. And in a similar way, Rev can be acquired either as part of Red Hat Cloud Infrastructure or standalone. Before I go on, I'm going to talk a bit about roadmap for Rev and timelines for the products. Any quick questions on that before I do some roadmap? Okay, so Rev 3.2 was released yesterday. I'm going to go through maybe the highlights of what's in the release, and then we're going to dig down. Tomorrow's a deep dive session tomorrow afternoon. I'm an Englishman living in the US, so I naturally presume that everyone speaks English. At school I was taught if they don't, you speak slowly and loudly and they'll understand you. That sadly doesn't translate into a UI, so continued work on localization of everything from the documentation to the landing pages that you hit to the user interface in multiple languages. One of the best new features we have in 3.2 is extensions, so UI plugins to allow third parties to extend Rev Manager. So whether it's an end user's application in the community or a third party, you can extend Rev to add extra functionality. So there's a few examples being demonstrated this week at Summit. HP is integrated Insight Control. So if you're running against a ProLiant system, when you land on a node, you get a lot more management information and functionality on ProLiant than if you're using any generic x86 hardware. NetApp are demonstrating their plugin that gives you storage management and offload. So snap clone, everything, the clonings happen underneath the covers rather than Rev doing cloning, the integration directly with the storage controller. Our support team are doing the plugins, so if you're using Rev and you hit a problem, you have a question, context sensitive, it knows the error message, it looks it up against our K-based system, but even let you create a support ticket right from within the UI. The community have chipped in. We've seen a plugin for Foreman provisioning, a plugin for Nagios that's shown here. But my favorite plugin is a sample plugin that was developed by the team. And disaster recovery is a big thing in virtualization. Symantec, by the way, announced an extension for their product, their VCS product, to support disaster recovery and remote site replication with Rev. So we've got most of the bases covered. However, there is one eventuality that they haven't covered within a disaster recovery product. So I think that we talk about differentiation. No other platform has this. So again, one of the sample plugins that we have within Rev. Exactly what the core support button does at the bottom, I'm not exactly sure, but I suspect you need a TAM subscription to get support to the UI plugin. Okay, so UI plugins, and you see a number of vendors announcing plugins to Rev to extend the functionality. Changes to our network management. One of the biggest ones for self-service and private cloud is to have permissions on your network infrastructure. So if I've got a logical network in my DMZ, I don't want anybody to be able to use it to run their BitTorrent server. So I provide network ACLs, so I give permissions on my networks. I'm going to skip through some of these, so we're running out of time. A lot of information we gather from the host. We're extending information we pull back from the virtual machine. It's often good to see the combination of the host and the network traffic, especially as we move to do SLA-based policies in the infrastructure. Hot switching of networks, so plugging from VLAN 120 to 130 without unplugging the NIC. So we've had hot plug of network, this is hot switch. Storage, a quiet release for storage. I consider 3.2 to be a technical debt release. I mean, when you see 3.3, you know why I'm saying that in preparation. So storage migration, storage vMotion was tech preview in 3.1, moved to fully supported in 3.2. CPU pass-through, so if you want to, we use like a lowest common denominator CPU. If you have a cluster with Haswells and the Halems, we'll default in the Halems across the board. we now allow you to pass the host CPU directly through to the VM rather than going with the abstraction. And quotas, so we've had quotas in the UI for quite some time, but now the user portal, the self-service portal, you can now see the quotas that you're consuming or that you're sharing with any colleagues in your team. Support for new CPUs, Haswell and Sol, a number of new reports, especially around VDI and for cloud providers. Official support for Windows 2012 and Windows 8. They were supported in 3.1 and RHEL 6.4, but we're adding improvements, especially around the guest agent support. And a commonly requested feature called delete protection. You're in a UI, you select a VM, you hit delete, and you hit OK, and you realize it was the wrong one. So you can now lock a VM, and you have to literally go into the configuration to uncheck the protection before it can be deleted. And a lot of features around VDI. So Spice is our competitor to RDP. Now, while we support RDP as well as VNC, Spice provides a richer functionality. So a proxy server to allow you to centrally manage all your connections, not opening connections to each of the hypervisors. Support for smart cards, especially for DoD customers with CAT cards and PIV. Dynamic resolution, I've got a window that's 1024 by 768. I drag my client window, now the VM will resize to whatever, 1280 by 800. So dynamically changing the resolution as you change the window. And the ability to set per device settings for users. So on this machine, I want to enable WAN options and disable USB and save that on this machine. Running short of time, so I've rushed through 3.2 so I can spend more time on 3.3. So Mission 3.2 I consider to be, it's a lighter release with a lot of work that's going on ready for 3.3, which is going to see a lot of the integration that we spoke about on the earlier slides. So we're targeting this for November. For storage, number 2 most commonly requested feature, live resize of virtual disks. A move to support VirtIO SCSI. It's a power virtualized SCSI controller that allows you to do SCSI pass-through to your disks. So for some clustering software, that's required. Most importantly, though, the first integration with OpenStack, so supporting the image service glance. So be able to import and export disks and templates between Rev and OpenStack and Rev 3.3. And then building on top of our snapshot support from 3.1, a new backup API, we're working with a number of vendors to support native backups with our agents within Rev. Quantum, the OpenStack network service, we're adding to 3.3, so that will be supported as probably as a tech preview in the first release to allow you to leverage Quantum for the various service providers. And on compute, a lot of changes around the way we handle creation of VMs. We're changing our dialogue. There's no more new server, new desktop. There's new VM. Moving to an instance type kind of model, similar to what's used in clouds. And integration with Cloud Init, which is the metadata service that OpenStack uses when a VM runs and it says, who am I? Give me my identity, give me some configuration information. We're going to be supporting Cloud Init within Rev. So again, we've got these shared services and metadata adds to that we can share between OpenStack and Rev. Live snapshots don't today support memory. That's being added, so we can snapshot a VM, not just a disk at a point in time, but the memory. And the number 1 most requested feature we have is to host the engine, the Rev Manager, on the Rev infrastructure without requiring Red Hat Cluster Suite. So high availability Rev Manager within the Rev infrastructure. Open LDAP supporting is obvious, and the SLA, there'd be a service level manager based on a project called MOM, I love that name, which is originally Memory Over Commit Manager, to do policies for CPU, quality of service, memory, and network. Storage we'll add later. So the last slide, from a timelines point of view, we released CloudForms 2 back in April. We've been running OpenStack with an early adopters program. Now we've had a tech preview program since summer of last year. We've had a high-touch early adopters program running in the US and in EMEA since, I think, back mid-April. And RDO is our community OpenStack distribution. So June, actually yesterday, Rev 3.2 And then early in July, R8CI that we discussed will be announced. And that will include CloudForms 2.0, Rev 3.2, and the new version of OpenStack Grizzly, which we're calling the 3.0 edition. And that will come out early July. I mentioned Rev 3.3, that's coming out in November with the first integration points for OpenStack for the common shared services, giving us Glance, Quantum, Metadata Service, and some others. And the next release of OpenStack, which is on a 6-month cadence, is coming out upstream in October. It typically takes us about 2 months to go from upstream to downstream for stabilization, certification. So I'm hedging my bets and saying December or January, but we're targeting December for 2 months from upstream. And then to round out the OpenStack integration, hopefully with Cinder, with Rev 3.4 in April. Now, I'm running out of time, so I'm going to go through the mandatory trademark statements and then leave you at this while we do Q&A. So I think we've probably got 5 minutes or so for Q&A, so how can I help?
I spoke with someone earlier about a version of OpenStack that'll run on a lighter RHEL stack. I didn't know if that fell somewhere in the timeline that you just went through up there, or whether you can speak to where that would or potentially fall
Were you talking about for the compute nodes or in general?
for the host node.
Okay, so we have something in Rev called Rev H, or Rev Hypervisor. So if you've used VMware, you don't have to admit it, but you probably have. There was ESX, which was a large footprint hypervisor, and ESXi was like a very small footprint, hundreds of megabytes hypervisor. For Rev, we have something called Rev H, Rev Hypervisor, which is just that. But it's a lightweight, just enough RHEL to boot up run the management agent. We had that for Rev. We're working on that for OpenStack. One of the challenges is that you often have plugins. So you might have a plugin for Quantum, maybe for Cinder that needs to go into the nodes. So we've developed a plugin infrastructure that will handle that. But that's on the roadmap, and that's hopefully later this year. I think most people will start off with RHEL, because it's included, but I like that model. I think it's a clean model, the stateless model. And if you've got questions at the end, I'm going to volunteer up the engineering manager who runs that project, who's sitting on my right, who's probably doing this now. If you've got any questions at the end, we can give a deep dive onto that. Yes, sir.
So can OpenStack support different storage technologies at the same time?
So OpenStack has the block service, so Cinder, or the volume service, and that has plugins, and there's a number of different plugins that you could use. There's a notion of a scheduler, so you might even want to have a way of deciding which storage you use. It could be tiered storage, let alone different storage types. So yes, it can, either done by the volume that you speak to or using the scheduler. So the question was, any plans for Rev to support different storage at the same time? So Rev has an artificial limitation right now where a logical data center is one storage type. That's something we'll be breaking in the 4.0 release. It was an arbitrary choice that took time to undo rather than any architectural limitation. Okay, if there's any other questions, then please come and grab me at the end. We've got a number of other sessions that you might want to attend covering KVM, OpenStack, Rev. I run out of space to put some CloudForms on here as well. Demos downstairs on the second floor in the expo hall. Plenty of our engineers, product managers, SAs are there to answer any questions. So thank you for your time.